Hello students, last class we are discussing about chapter heat. So this is your heat chapter, topic is heat. So we have discussed about this heat transfer. So we have not discussed about heat transfer yet. We have to discuss about that, and we already discussed about the thermometer. That means instrument used to measure the temperature, and we have discussed the temperature and its scales. The degree of hotness or coldness of a body is called as temperature. It is SI unit is Kelvin. It is expressed in Kelvin, degree Celsius and Fahrenheit. So after that we have discussed thermometer is the instrument that is used to measure temperature. There are two types of thermometers mainly: clinical thermometer and laboratory thermometer. Of course, maximum minimum thermometer is also there and digital thermometer is also there, but we are not discussing those things here. We are discussing mainly thermometers, that is clinical thermometer, laboratory thermometer. We have discussed how the clinical thermometer is, what are the precautions you have to use in handling that, and which is the liquid that is present there, and how we have to measure that, what is the scale. So we have discussed all those things. Okay, so now in this class, last class also we have discussed again about laboratory thermometer also, and we have discussed what is the temperature range and where it is used, how it is used, and we have to discuss the precautions of laboratory thermometer in this class, and after that we can go for next concepts. So as told, clinical thermometer is used in clinics, laboratory thermometer is used in labs. The temperature range of it is already discussed. The clinical thermometer is 35 to 42 degrees Celsius, because human body temperature is never processed below 35, above 42. Okay, so the human body temperature in normal we can say 37 degrees Celsius. The normal temperature of a human body is 37 degrees Celsius. Okay, so for that reason, clinical thermometer is maintained at 35 to 42 degrees Celsius. But when it comes to laboratory thermometer, there is a wide range of temperature we can see. For example, we can in a solution we can measure a very low temperature and of course a high temperature too. If you want to measure the boiling point of water, you want 100 degrees Celsius. If you want to melting point of water, you want 0 degrees Celsius. So for that reason, the laboratory thermometer is maintained from minus 10 degrees Celsius to 110 degrees Celsius. This is the temperature range of laboratory thermometer. This is the human body temperature. Human body temperature. Okay, normal human body temperature. Normal human body temperature, that is 37 degrees Celsius. Laboratory thermometer range is minus 10 degrees Celsius to 110 degrees Celsius. These questions might be asked. And this one 35 to 42 degrees Celsius, that is our clinical thermometer range. Clinical thermometer range. In both the cases, mercury is used as a substance. Okay, so this one you understood. Now let me see precautions of laboratory thermometer. What are the precautions you should take while handling the laboratory thermometer? So laboratory thermometer should be kept upright and hot tilted. Precautions in using laboratory thermometer. Okay, precautions in handling laboratory thermometer. Laboratory thermometer. What are the precautions we have to take in handling the laboratory thermometer? Okay, precautions in handling This one you see laboratory thermometer. Laboratory thermometer. Okay. See what are the precautions we have to take in handling the laboratory thermometer. First one, the laboratory thermometer should be kept uptight and hold tilted. The laboratory thermometer, so you have to write down with me the laboratory thermometer, or you can write later. The laboratory thermometer should be, I think you can see, now we will see. The laboratory thermometer should, okay, sit. The laboratory thermometer should be kept uptight and hold tilted. Okay, the laboratory thermometer should be kept upright, so not tilted and not tilted. I think, can you observe this? Okay, so just a minute, I am going to change it. Okay, should not tilted. Okay, right. The laboratory thermometer should be kept up tight and not tilted. Okay. See here, the laboratory thermometer should be kept uptight and not tilted. This is our first point. Okay, let me write the second one. The bulb should not touch the surface of the container. The bulb should not touch. Should not touch the bulb should not touch the surface of the container. Surface of the container. The bulb should not touch the surface of the container. This is our second point. See, the bulb should not touch the surface of the container. These are the precautions in handling thermometer. What is our third point? The bulb should be surrounded by the substance from all around. The bulb should be surrounded. The bulb should be surrounded by the bulb should be surrounded by the substances all around. Substances all around. Substances all around. Okay. See here. These are the three important points that we are seeing. Okay. See how we have to consider these 3 points. What are the precautions in handling laboratory thermometer? First one, the laboratory thermometer should be kept upright and not tilted. It should not be tilted. Okay. See, if you want to see the laboratory thermometer, okay. So when you come to school, I will show it. Okay. So when you are handling the laboratory thermometer, should be kept upright. That means it should be kept uptight also. Okay, sorry, it is upright. I have written spelling mistake. Okay. It should be kept upright and not tilted. That means it should be straight. Laboratory thermometer limit straight hidibeku. Okay, hing tilted agidre it shows wrong temperature. Swalpu adana bend mado agilla. It should be exactly 90 degree upright, we can say. So then it shows correct temperature. Otherwise it will not show the correct temperature. So the first thing is, when you are handling the laboratory thermometer, you should handle it upright. You should keep it upright. It should be kept upright. It should not be tilted. That is your first point. Second one, the bulb should not touch the surface of the container. So in that there is a bulb. As last class I have shown you, in that there is a bulb at one end. It should not touch the surface of container. For example, you see here. Okay. For example, if you are measuring a liquid. Okay, liquid is present like this. Okay, when you keep this laboratory thermometer here, okay, so if you keep the thermometer here, here it is touching, this should not happen. Okay, so it should not happen means, okay, okay, just I am drawing this. Okay, rough diagram I am giving. Here it is not touching the surface, but earlier it was touching the surface. That means the laboratory thermometer should not touch the surface of the container. If it touches the surface of the container, what happens? It measures the temperature of that surface. That means this temperature of this liquid will go off. That is why the laboratory thermometer should not touch the surface of the container. The laboratory thermometer should not touch the surface of the container. That is our second precaution. What is my third precaution? That is when handling laboratory thermometer. The bulb should be surrounded by the substances all around. This bulb should be surrounded by the substances. It should not be kept free. Why? If it is kept free, what happens? It measures, it takes the temperature of surrounding also. If it is kept like this, it takes the temperature of this air also. Then it is of no use. Okay, when it wants to measure that liquid temperature, then all the liquid particles has to surround the bulb. There should not be a little bit gap also, because it has to take all the temperature from all the molecules. Then only it gives the correct temperature. Otherwise, some temperature will become less, or it misleads the temperature. That is why the bulb should be surrounded by the substances all around. These are the things you have to remember. These are the precautions in handling laboratory thermometer. Just go through this once again. So take a screenshot of this. I am going to give you 25 seconds or 20 seconds. Either you write down this or take a screenshot of this. This is very much important question. Write down or take a screenshot. Okay, I hope you are done with this. Okay, let me rub this. Okay, next I will move to concept called choices of thermometric liquids. How we have to choose the thermometric liquids? Choice of thermometric liquid. Thermometric liquids. Choice of thermometric liquid. See what happens. Choice of thermometric liquid. Just a minute, this laptop is not working. Choice of thermometric liquids. How we choose the thermometric liquid? So this thing you should remember. First, it should have low specific heat capacity. It should be good conductors of heat. It should be opaque. It should have high boiling point and low freezing point. It should have uniform rate of expansion. These are the points. So let us see one by one of them. First one, it should have low specific heat capacity. It should have low specific heat capacity. Low specific heat capacity. So we are using here what? Mercury. So mercury should have all these characters. Okay, when we choose the thermometric liquid, we should consider these things. it is should be the good conductor of heat. It should be the good conductor of heat. It should be the good conductor of heat. It should be the good conductor of heat. Third one, it should be opaque. It should be opaque. It should have high boiling point and low freezing point. High boiling point and low freezing point. Low freezing point. It should have high boiling point and low freezing point. It should have uniform rate of expansion. Uniform rate of expansion. Okay. See here. I will explain you one by one. When you are choosing a thermometric liquid, or say when I am choosing a thermometric liquid, I hope you can see now all these things. See what happens. First thing I have to consider is low specific heat capacity. That means what? What is specific heat? Okay. Specific heat means it is the heat required to increase the temperature by 1 degree Celsius. Specific heat means it is the heat required by 1 kg of a substance to increase its temperature by 1 degree Celsius. For example, now if mercury is used or if other liquid is used, so suppose I will give example, here is X liquid, here is Y liquid. This X liquid takes heat energy of 100 joules. For example, I am telling, it is not correct exactly. If this takes 100 kilojoules or joules of heat to increase the temperature by 1 degree Celsius. For example, it is 37 now. If it want to go for 38, it will take 100 kilojoules of heat. ಈ 37 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗೆ ಅದ ಇದು ಟೆಂಪರೇಚರ್ ಒಂದು ಲಿಕ್ವಿಡ್ ಒಳಗೆ ಹಾಕಿವಿ, ಇದರ 37 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅದ ಥರ್ಮೋಮೀಟರ್. ಅದು 38 ಆಗಬೇಕಂದ್ರೆ ಅದಕ್ಕೆ 100 ಕಿಲೋ ಜೌಲ್ಸ್ ಆಫ್ ಹೀಟ್ ಸಪ್ಲೈ ಆಗಬೇಕು. ಅದ y ಏನದಿ 30 ಕಿಲೋ ಜೌಲ್ಸ್ ಆಫ್ ಹೀಟ್ ಸಪ್ಲೈ ಆದ್ರೂ ಸಾಕು, ಇದು 37 ಇಂದ 38 ಗೆ ಹೋಗ್ತದೆ. That means the specific heat capacity of y is less compared to this. Then we have to say that we have to choose y. Why? Because it is having a low specific heat capacity. Why? That is 30 kilojoules. That is example I am taking. It will take only 30 kilojoules to increase its temperature by 1 degree Celsius. Then I can say that it should have low specific heat capacity. Okay. Second one. They should be the good conductors of heat. They should be the good conductor of heat. That means that liquid should be the good conductor of heat. If it is not good conductor of heat, then it will not take all the heat. Some of the heat may get wasted. Then it will show the wrong temperature. Suppose a thermometer is kept in our mouth, suppose, okay, then it has to take all the temperature of the surrounding inside the mouth. If it doesn't take, it will show the low temperature, it will show the wrong temperature. That is why it is very important to choose such a liquid that it should be the good conductor of heat, that it allows all the heat, that it absorbs all the heat and measures the temperature. That gives us the exact temperature of our body. Or if you are measuring in laboratory thermometer, that gives us the exact temperature of the lab or exact temperature of the solution in which you are measuring. Okay. Third one, it should be opaque. You know all about this word opaque and transparent. If you are seeing something from a middle one, that means the object which does not allow the light to pass through. For example, if I take this mobile, I am taking the mobile. Okay, so I cannot see this mobile through the other person. If another person is standing here, I cannot see by this mobile without owning the camera. Camera should not be considered. Okay, without making the camera on. Andra illo person adanandra a person nanaga idur through ಕಾಣಿಸುವುದಿಲ್ಲ. So then I have to say this is opaque. ಅದ ಒಂದು ನಾನು ಗ್ಲಾಸ್ ತಗೊಂಡ್ಬನ್ನಿ ಅಂದ್ರೆ ಇಲ್ಲಿ ಗ್ಲಾಸ್ ಇದ್ರು ಆಚೆ ಕಡೆ ಇರೋ ಪರ್ಸನ್ ಕಾಣಿಸ್ತಾನ. ನೀವು ಬಸ್ನಾಗ ಹೋಗ್ತಿರ್ತೀರಿ, ಗ್ಲಾಸ್ ಹೊರಗಿನ ಎಲ್ಲ ಕಾಣಿಸ್ತಾವು. Those are transparent. ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಅಂದ್ರೆ ಯಾವುದು ಲೈಟ್ ಅನ್ನ ಅಲೋ ಮಾಡ್ತದ, ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಯಾವುದು ಲೈಟ್ ಅನ್ನು ರೆಸಿಸ್ಟ್ ಮಾಡ್ತದ, ಅದು ಒಪೆಕ್. ಅಂಡರ್ಸ್ಟುಡ್? ಸೊ ಗ್ಲಾಸ್ ಇಸ್ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್. ಗ್ಲಾಸ್ ಒಳಗೆ ಹೆಚ್ಚು ಕಡೆ ಇದ್ದವ್ರು ಕಾಣಿಸ್ತಾರಿಲ್ಲ, ಅವು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್. ಓಕೆ, ಒಪೆಕ್ ಅಂದ್ರೆ ಕಾಣಿಸೋದಿಲ್ಲ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಮೊಬೈಲ್, paper. If you take paper here, other person of that side will not seen by you. Then we can say that that is opaque. Transparent is the one which allows the light to pass through them. Opaque are the one which does not allow the light to pass through them. I hope you understood. This should be opaque. This should not allow the light to pass through them. If it is so, what happens? Heat energy is having some kind of light also. Sometimes light gives little bit of heat energy. Okay, that should be get passed if it is transparent. So that is why it should be opaque. And we can see that mercury is a opaque one. Fourth one, high boiling point and low freezing point. It should have high boiling point and low freezing point. Why? Suppose if you are increasing the temperature, suppose if you want to measure the temperature of 100 degrees Celsius, that is boiling water. If it wants to measure the temperature, then it should have more than 100 degree temperature, then only it records. Otherwise, if it is only boiling at 80 degrees Celsius, then it will boil and go at 80 degrees Celsius. You will not at all reach 100 degrees Celsius. ತಿಳಿತಲ್ಲ, ನಿಮಗೆ 100 ಡಿಗ್ರಿ ಟೆಂಪರೇಚರ್ ಮೆಜರ್ ಮಾಡಬೇಕಾಗಿತ್ತಂದ್ರೆ ಇದು ಅಟ್ಲೀಸ್ಟ್ 100 ದಾಟ್ರೆ ಇರಬೇಕು, 120 ಡಿಗ್ರಿಗೆ ಬಾಯ್ಲ್ ಆಗ್ತಿರ್ಬೇಕು. ಅಂದ್ರೆ 100 ಮಟ್ಟ ಸಮಾಧಾನಲೇ ಹೋಗ್ತದೆ. ಇಲ್ಲಾಂದ್ರೆ ಇದು 80ಕ್ಕೆ ಬಾಯ್ಲ್ ಆಗಿ ಹೋತಂದ್ರೆ 100 ಯಾವಾಗ ಹೋಗ್ತದೆ, ಇಲ್ಲ ಬಾಯ್ಲ್ ಆಗಿ ಹೋಗ್ಬಿಡ್ತದೆ. 100 ರೀಚೇ ಆಗೋದಿಲ್ಲ, ಅಂದ್ರೆ ನಿಮ್ಗೆ ಬಾಯ್ಲಿಂಗ್ ವಾಟರ್ದ ಟೆಂಪರೇಚರ್ ಸಿಗುವುದಿಲ್ಲ. ಅಂಡ್ ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಲೋ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್. ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಅದ್ರದ್ದು ಏನಿರಬೇಕು, ಬಹಳ ಕಡಿಮೆ ಇರಬೇಕು. ಇಲ್ಲಾಂದ್ರೆ ಫ್ರೀಸ್ ಆಗೋದ್ನಾಗ ಮೊದಲು ಫ್ರೀಸ್ ಆಗಿಬಿಡ್ತದ. ನಿಮ್ದು ಐಸದ್ದು ಮೆಜರ್ ಮಾಡ್ಬೇಕೀಗ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. ಸೊ ಇದೇ ಏನ್ರೆ 10 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಫ್ರೀಸ್ ಆಗಿ ಹೋಗ್ಬಿಡ್ತಂದ್ರೆ 0 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ರೀಚ್ ಆಗೋದಿಲ್ಲ. ಸೊ ತೆಳಗೆ ಹೋಗೋದ್ನಾಗ ಪೂರ್ತಿ ಲೋ ಇರ್ಬೇಕಿರೋದು ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್. ಫ್ರೀಜಿಂಗ್ ಅಂದ್ರೆ ಕರಗುದು. ಇಟ್ ಶುಡ್ ಹ್ಯಾವ್ ಲೋ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಆರ್ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್. ಬಹಳ ತೆಳಗಿರ್ಬೇಕು ಲೋ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಬಹಳ ಹೈ ಇರ್ಬೇಕು. ಓಕೆ, ಸೊ ಹಿಂಗ್ರಿ ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಫುಲ್ ಹೆಚ್ಚಿರ್ಬೇಕು, ಹೈ ಇರ್ಬೇಕು. ಸಾರಿ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಫುಲ್ ಹೈ ಇರಬೇಕು, ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಫುಲ್ ಲೋ ಇರಬೇಕು. Okay, so this is freezing point, FP or melting point ಅಂತ ಕರೀತಾರೆ. ಇದು BP, boiling point. ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೆಚ್ಚಿರಬೇಕು, ಫ್ರೀಜಿಂಗ್ ಪಾಯಿಂಟ್ ಕಡಿಮೆ ಇರಬೇಕು. ನೆಕ್ಸ್ಟ್ ಒನ್, ಯೂನಿಫಾರ್ಮ್ ರೇಟ್ ಆಫ್ ಎಕ್ಸ್ಪಾನ್ಷನ್. ಸೊ ದಿಸ್ ಇಸ್ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್. ಯೂನಿಫಾರ್ಮ್ ರೇಟ್ ಆಫ್ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಅಂದ್ರೆ that substance has to expand in a uniform way. For example, if it wants to increase its temperature 37 ಇಂದ 38 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಗೆ ಹೋಗಬೇಕಾದ್ರೆ 100 ಜೌಲ್ಸ್, ಸಾರಿ 30 ಕಿಲೋ ಜೌಲ್ಸ್ ತಗೋತಾನೆ ಕೊರಿಯರ್. 38 ಇಂದ 39 ಗೆ ಹೋಗಬೇಕಂದ್ರೆ 30 ಕಿಲೋ ಜೌಲ್ಸ್ ತಗೋಬೇಕಾಗುತ್ತೆ. 39 ಇಂದ 40 ಗೆ ಹೋಗಬೇಕಂದ್ರೆ 30 ಕಿಲೋ ಜೌಲ್ಸ್ ತಗೋಬೇಕು. Then we can say that it is having the uniform rate of expansion. Uniform ಆಗಿರ್ತದಲ್ಲ, normally it is going with uniform rate of expansion. Then we have to say that it is having a good choice of thermometric liquid. It is good for choosing the thermometric liquid. It should have uniform rate of expansion, that is it's expanding in a uniform way. Okay, then we have to say that it should take the proper heat energy and it should expand. So expansion in the uniform way, we should say that is the uniform rate of expansion. So this all will be satisfied by mercury. So that is why mercury is used as one of the thermometric liquid. So please note down this. Okay, you can pause the video, note down, or you just take the screenshot and note down. So these are the important point you have to consider when you are choosing a thermometric liquid. So watch out those. It should have low specific gravity. It should have been a good conductor of heat. It should be opaque. It should have high boiling point and low freezing point, and it should have the uniform rate of expansion. These are the things you have to consider when you are choosing a thermometric liquid. The choice of the thermometric liquid has to be done on these 5 concepts. Okay, so we'll see the remaining things in the upcoming classes.